Welcome back to another trigonometry video. In this video, we are going to look at properties of the 6 trig functions. And then we're going to get an idea of what they look like if we were to graph them. And then we're going to look at some identities. So let's get started. So everything we do is going to relate back to the unit circle. So we're going to have to keep that unit circle in mind. You may want to have it out for this. I'm going to pull it up as I need it for the class, for this worksheet on domain, range, period, and so forth. So we're going to start with the sine function. So I've got this table set up. I've got sine function over here, and then I'm going to find some domain, range, period, symmetry, and so on. But we're going to actually start by looking at points to graph on this, and that's where that unit circle is going to come in handy. So we're asking what happens when x is 0 or when theta is 0, just to be consistent with this. So when theta is 0, we're thinking about the sine of 0. And if we're looking at our unit circle, so we're looking at sine of 0. So that's the y-coordinate, remember? The y-coordinate is going to be 0, 0. And then we're going to look at sine of pi over 2. So we're going back to our unit circle here. Pi over 2, it's 1. And then we're going to look at sine of pi. Going back to our unit circle. Sine of pi is 0. And I'm going to go backwards and I'm going to catch a few. So I'm looking at sine of negative pi over 2. Negative pi over 2 is going to be the same angle as 3 pi over 2. And that y-coordinate is a negative 1. And then sine of negative pi. Negative pi is going to be read this way. Excuse me. And the sine of that angle is going to be the same as the sine of pi, which is going to be 0. So we've got these coordinates that we're going to graph. So at 0, we're at 0. At pi over 2, we are at 1. At pi, we're back at 0. At negative pi over 2, we're down here at negative 1. And at negative pi, we're at 0. So connecting the dots, this is going to look like this. And then we're going to just kind of keep repeating this thing over and over and over again. So let's start by looking at domain. Domain is what kind of things can you plug in? With the sine function, remember, is defined as y over r. And we can plug in any theta value and we can get out something in terms of the sine. So there's no restrictions there because, think about what r has to be. R is the radius of our circle. It has to be something that's not 0. Otherwise, you don't have a circle if the radius is 0. So there's no restrictions on the domain. The range, though, if we were to look at this graph, that range only goes from negative 1 to 1. And that's going to happen if we were to keep plugging in values like 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and so on. We're going to see this kind of wave pattern happening for the sine function. So now we need to talk about period. What is the period? The period is how frequently it repeats. And we can see a repeat happening from here to here, and then we would see the same kind of thing happening if we were to list more values. So our period here would be the distance from here to here, which would be 2 pi. And then symmetry, this guy's going to have some odd symmetry, is symmetric about the origin. So we're going to do the same kind of thing for cosine. What is the cosine of 0? Well, to find the cosine of 0, we're going back to our unit circle. The cosine of 0 is 1. And now we're looking at the cosine of pi over 2. Going back to our unit circle. Cosine of pi over 2 is going to be 0. Remember, that is the x-coordinate. Cosine of pi is over here at -1. And now we're looking at cosine of negative pi over 2. Negative pi over 2 is the same angle as 3 pi over 2. And that's going to have a value of 0. And then if we look at negative pi is the same thing as the angle pi. And the cosine is going to be -1 there. So if we were to graph these, 0, 1, pi over 2, 0, pi -1, negative pi over 2, 0, negative pi, -1. So we're going to see this kind of thing happening here. So there's one iteration of our cosine function, and that's also called a period. So let's talk about domain, range, and all that fun stuff. So domain, once again, domain's going to be all real numbers. There are no restrictions because of the definition of cosine. Cosine's defined as x over r. The range is going to go from -1 to 1, just like the sine function. This cosine function is going to be a wavy function, just like the sine function. The difference is really where it's kind of starting. On the y-axis, cosine starts at 1, whereas on the y-axis, sine starts at 0. So we could actually get one from the other by doing a horizontal shift. That's pretty cool, right? So when we talk about period, how often is this repeating? Again, that period is going to be 2 pi. You can see that there. That's where the repeats is starting to happen. And then symmetry, this guy's even. If we were to fold that along the y-axis, the left hand and the right hand sides would match up perfectly. And now let's look at our tangent function. So remember the definition of tangent. Tangent's defined as y over x. So now we're going to have some domain restrictions. So let's first come up with this chart, and we're going to use that unit circle to be able to do that. So we're looking at negative pi over 4. Negative pi over 4 is down here. Tangent is y divided by x. So negative square root of 2 over 2 divided by positive square root of 2 over 2 is a -1. And then we need to find the tangent of 0. Tangent of 0 would be looking at this coordinate here. Y over x, 0 over 1 is 0. Tangent of pi over 4 would be y over x, square root of 2 over 2 divided by square root of 2 over 2 is 1. Tangent of 3 pi over 4 here. Y over x again is going to give us a -1. Tangent of 0. Tangent of pi. Y over x, 0 over -1 is 0. And then 5 pi over 4. Negative square root of 2 over 2 divided by negative square root of 2 over 2 is a +1. So you can kind of start seeing a repeat in these patterns here, right there, right? So that's a hypothesis for now, but let's graph and let's see what's going on with this. So negative pi over 4 and -1, 0, 0, pi over 4, 1, 3 pi over 4, -1, pi 0, 5 pi over 4, 1. So let's examine this just a little bit closer. When we talk about domain of the function, we got to think about tangent and what we have here. We know that x can't be equal to 0, right? So the tangent function is y over x. We could also think about it in terms of sine over cosine. Now, to figure out domain, you kind of think about domain and vertical asymptotes together, right? Because if it's a vertical asymptote, it has to be a domain restriction. We need to know where the issues are. The issues happen where that denominator is equal to 0. So we need to know, where is the cosine of theta equal to 0? So if we look at our unit circle, that's happening here at pi over 2, and it's happening here at 3 pi over 2. Okay, but we don't just have to think about one revolution of the unit circle. We got to think about every single revolution. So if we were to go around again, this would be at 5 pi over 2, and then at 7 pi over 2. And then 9 pi over 2 and 11 pi over 2 and so on. So there's a lot of places where this is going to have some kind of domain restriction, right? So the question is, how do we write that concisely? Well, we can write that in terms of 2k plus 1 pi over 2, where k is an integer. So I've thrown a lot of different symbols at you. So let's talk about what these symbols mean. First off, when we write 2k plus 1, that's the way to write an odd number. Okay, we can write any odd number that way as long as we define k in a certain way, where k is an integer. Now, what is an integer? An integer is a whole number that's either positive or negative. And that's what the symbol means here. That funky E, that means element of, and that funny Z means integer. So when we talk about domain, the domain is everything except theta cannot be 2k plus 1 pi over 2. Anything else is fine. Okay, the range for this guy is going to end up being all real numbers. The period, this guy repeats every pi units, and you can kind of see that going on here. From here to here, you see the repeat, and that distance is going to be pi units. And then where do vertical asymptotes happen? They happen where, and I'm going to use theta here, 2k plus 1 pi over 2 for k being an integer. Tangent function is an odd function. So if we were to draw in those asymptotes, we're going to have an asymptote here, we're going to have an asymptote here, and we're going to have another asymptote here. So here's your tangent function and what it looks like. It's doing this kind of fun thing. The hardest part, I think, about the tangent is figuring out what is that domain going to be and what does that mean in terms of vertical asymptotes. So those are the three big, sine, cosine, and tangent. You may want to take a few minutes, pause the video, see if you can finish this worksheet for secant, cosecant, and cotangent, and then come back and check your answers.